Self-driving cars are a new, rapidly improving concept that has greatly impacted the autonomous industry. The concept of a car being able to drive itself is an innovation that can greatly impact society. At the University of Calgary, Osaze is a team lead of the Perception Division for an autonomous motorsport club, where students look to improve their skills in machine learning and AI. The use of technology makes our tasks easier to do. Things we do on a regular basis, such as driving, have some form of computer assisting us to make the process much simpler. Intelligent computer systems can and do benefit us all, but how does autonomous AI work? I asked Osaze if I could get some insight on how it works, and basically, autonomous AI uses many different components such as sensors, GPSs, radars, LiDAR, and cameras to give the computer real-time data which makes the car produce control signals on how to operate and drive. Here at U of C, Osaze and his team are working on their own self-driving car and have started to apply the concepts on their own model, with the hopes for the club to grow and eventually use what they've learned on a much larger scale.
Come out. Oh, there it is.
Hi, my name is Osaze. I'm a third-year geomatics engineering student and the project lead of the Perception Division of the Autonomous Electric Motorsport team.
I believe that I'm an innovator because I'm working on a project that is very new. Even though OpenCV and computer vision software has been around for at least 20 years, just recently with the releases of TensorFlow and other deep learning frameworks, are we able to take on a project of this magnitude at student level. So I feel like the combination of electrical engineering, photogrammetry, software, and mechanical engineering is what makes me and my team very innovative. Recent events definitely have changed the way we do things and made us more creative as a team. So first things first, we had to move all our meetings from the makerspace to all online, so we use Discord now for our meetings. And second, we had to pick somebody who would actually have the physical car. And the person that ended up with the car was a computer science student. And I think it's been a very interesting experience for him because he's learned a lot of electrical engineering concepts. Because anytime there's an issue, he's getting directed on how to fix it by the electrical engineers. So I think he's learned a lot. But overall, I don't think the pandemic affected us as heavily because a lot of the stuff we're working on in the stage right now is software-based, and we can do that all remotely.
For sure, once you overcome the stigma of the self-driving car or giving complete control away to your vehicle to navigate, I think you'll see the upsides of autonomous vehicles. So you'll see a drastic decrease in accidents, as 94% of accidents are usually a function of human error, but you'll also see the disabled and older people being able to navigate around by themselves now. They don't need any additional services. And I think that's a fantastic argument for self-driving cars just taking over the automotive market. Well, I've always been interested in programming, spatial data science, and just sci-fi. So this was like one of the best intersection points of all three of those. When I first won this autonomous vehicle conversation was starting a couple of years ago, I was excited but a little bit apprehensive about it, and I felt like this project would help me understand the inner mechanisms of autonomy. And now I think we're in a very interesting place where we have the tools to create machines that can outperform humans in most environments. AI is pretty much a part of every industry now. You can see it in security, surveillance, sports analytics, agriculture, farming, livestock management. You can even see it in retail, like in Amazon and Netflix, how they recommend you products that they think you would like to see. And now you're seeing AI make more of an appearance in healthcare and medical imaging analysis as well. I think for sure right now it's getting very good at completing one task, but for it to be truly intelligent, you need to be able to complete multiple tasks without a break. You need to be able to switch from doing A to B. I think a great example example of this was Google a couple of years ago. They had an AI system that could complete 49 games, but in between each game, that model needed to be retrained for the next upcoming game. So I feel like more complex models and more advancements in machine learning and neural networks will put us in a place where we have an AI that is actually intelligent and can switch tasks easy, that isn't super specialized.
Definitely for me, the most fun part is working in a multidisciplinary engineering environment. So I'm working with software engineers, electrical engineers, mechanical engineers, and some computer scientists. So I've been able to build on my knowledge quite a lot here, and I've been able to experience the engineering design process, how it really is, how sometimes you're progressing a lot and then you stagnate for a while. I'm really happy with the friends I've made and the relationships I've built and the network I've built now. And I think this project has definitely helped me discover where I want to work and what field I want to work in when I graduate. Definitely something to do with machine learning and the applications of photogrammetry in real world situations.